Hello, scholars. Today is Wednesday, and normally we do a full relooping review Wednesday. Today we're going to do something a little different and do half review and half work on current material. So take a couple minutes, solve your do now, and then enter your answers. All right, so this first one is a unit rate problem, what we have been reviewing a little throughout the week. Hopefully you did not use a calculator and worked out all of your fraction work, since this could be on the inactive part of the EOG. So I'm looking for the rate at which the plant is growing in inches per week. I'm looking for how many inches it grows for every 1 week, so it's a unit rate. The word rate also signals a relationship and a ratio. So my comparison in this problem is inches to weeks. We're given that the plant grows a half an inch every 3/7 of a week. To get my unit rate, I just need to divide. So 1/2 divided by 3/7. Dividing fractions, I keep, change, and flip. Multiply straight across, we get 7/6. If we're going to turn that back into a mixed number, we divide. So 6 goes into 7 one whole time. There would be 1 as a remainder, and 6 is still the denominator. So it grows 1 1/6 inches every single week. Always be sure that you are checking and correcting any mistakes. Number 2, we are asking for the volume of a triangular prism. Every time we have geometry or formulas, the first thing you do is write the formula. So to find the volume, I do base times height divided by 2 times the height. So everything in this parentheses is just the area of the triangle, the triangular base, and then the second height is the height of the 3D figure, or the depth. It's what connects your two triangular bases. So from here I'm going to fill in my numbers. The base of the triangle is 4 times the height of the triangle is 1.5. That is the height because it forms a right angle with the base. I'm going to divide that all by 2. Multiply it by the height of the whole figure, which is 6, because 6 connects the front triangle with the back triangle. So what's in parentheses? 4 times 1.5 is 6. 6 divided by 2 is 3. Times 6, my volume is 18 cubic meters, or meters cubed. Volume is always measured in cubic units. Today's number review is our ASMD with decimals. So take 2 minutes. Try to get this done in 2 minutes, max 3. Do not use a calculator. We're practicing this by hand for the inactive part of the EOG. Solve, enter your answers, and then we'll review. All right, so adding decimals, we just have to remember to line up the decimal point. Plus, so here's 0.9, which means I add a 0 to make it the same length. Bring my decimal all the way straight down in your answer. 4 plus 0 is 4. 4 plus 9 is 13. Carry the 1. So we get 9.31 for the first problem. Number 2. 4.6 minus, again, I'm lining up the decimal point when I'm adding and subtracting. So if this top number is not the same length, it doesn't have a number in the hundreds place, I can always add a 0. Can't do 0 minus 4, so I'm going to borrow. This becomes a 10. 10 minus 4 is 6. I can't do 5 minus 8, so I borrow from the 4. That becomes a 15. 15 minus 8 is 7. Decimal point is brought down. 3 minus 2 is 1. So 1.76 should be your answer for number 2. Number 3, multiplying. With multiplying decimals, we want, and it's the easiest if you put the longest number on the top. Doesn't matter if it's the smallest because we are lining up the last digits. You do not line up the decimals when you multiply. You line up the last digits. So it's okay that 11 was the first number here, but we put it second here. 5 times 1 is 5, 1 times 3 is 3, 1 times 4 is 4. Bring a placeholder down, 0, 1 times 5 is 5, 3, 4. Add it up. To figure out where my decimal point goes, I count how many numbers are after the decimal in the original numbers, which is 2. So it means I move it over 2. So our answer is 47.85. All right, and our last one, division. 120.24 divided by 8. I don't need to move any decimals since my 8 is already a whole number. So I just bring the decimal above the division bar. 8 goes into 12 one time. 1 times 8 is 8. Subtract, we get 4. Bring down the 0. 8 goes into 45 times. 8 times 5 is 40. Nothing left over. Bring down the 2. Tricky part. 8 doesn't go into 2. Before I can bring down that 4, make sure you've got your 0 up here. Shows that it goes into 2 0 times. Now I can bring down the 4, and 8 goes into 4 3 times. So 15.03 is your final answer. Great job if you got all 4 of these correct. Again, make sure you correct any mistakes before moving on. All right, so now we're going to do a little brain refresher on unit rate comparisons. Again, we are not using a calculator with unit rate. This could be on the inactive part. So let's do this first one together. Brandon drove 10.5 miles in 1.5 hours. Natalie drove 9 miles in 2 1/4 hours. Who drove at a faster rate? In order to accurately compare, we need to find their unit rate. So how many miles are they going per hour? So I'm going to need to find Brandon's rate of speed, and I'm going to need to find Natalie's rate of speed. So again, to figure out speed, we're comparing how many miles they can go per hour. So Brandon drove 10.5 miles in 1.5 hours. So now I need to divide this out. 10 1/2, again, all by hand, by 1 1/2. Always convert when we're dividing mixed numbers to improper fractions. So 10 times 2 is 20, plus 1 is 21/2, divided by 3/2. Keep, change, flip, multiply straight across. I get 42/6, and 42 divided by 6 is 7. So that means he only drove 7 miles per hour. So there must have been some traffic or construction for him to be driving that slow. All right, so let's look to Natalie now. Again, we're going to compare miles to hours. She drove 9 miles in 2 1/4 hour. So I'm going to divide this out. 9, I'm going to put the whole number over 1, divided, by 2 1/4. Just like before, convert this to a mixed number, or improper fraction. 9/1 divided by 4 times 2 is 8, plus 1 is 9, over 4. Keep, change, flip. 9 times 4 is 36, divided by 9, and I get 4. So that means she was only going 4 miles per hour. So now I need to look to see who's faster. Brandon was 7 miles per hour. Natalie was 4 miles per hour. If you are going faster, you are going farther. So Brandon drove at a faster rate. So automatically I can cross off B and D. Now I need to know how much faster he was going. So Brandon drove either 4 miles per hour faster or 3 miles per hour faster. In order to figure out how much more, we need to subtract. So he was driving 7 miles per hour. She was driving 4. So he was driving 3 miles faster. So our answer is C. When we're talking about faster rates, the larger number is what we want. That means you go farther in the same amount of time. Now it's your turn to practice. Solve this problem without a calculator, show all your work, and then enter your answer. All right, so this one is a very similar one. I'm comparing two people's speed. So I'm going to separate my board into Amy and John. I'm looking for who would jog farther in 1 hour and by how much. I see that I'm doing rate, so I am comparing miles per hour. So I can fill in my numbers. Amy jogs 1/3 of a mile every 1/15 of an hour. John jogs 1/5 of a mile in 1/30 of an hour. Unit rate, just need to divide. 1/3 divided by 1/15. Keep, change, flip, multiply straight across. I get 15/3, and 15 divided by 3 is 5. So this is saying that Amy jogs 5 miles per hour. Now let's go to John. Unit rate, got to divide. 1/5 divided by 1/30. Keep, change, flip. 30/5 equals 6. So he jogged 6 miles per hour. So if he jogged 6 miles per hour, Amy only jogged 5, that means John is faster. He went farther in the same amount of time, which was an hour. So I can cross A and D off because John ran farther, but by how much is 1 mile. So John ran farther by 1 mile per hour. Be sure you fix any mistakes before moving on to the next one. Try this second one on your own. Again, no calculators, all by hand. All right, very similar, except now we've got animals instead of people. I also don't see any fractions, but I see decimals. So I'm again looking for which animal ran faster and by how much. So I'm going to have to do 2 different unit rate problems and subtract to compare. So I'm going to first work out the cheetah's speed. Looks like I'm comparing miles per minute, which is fine. We'll just compare how far they run for 1 minute instead of 1 hour. So 6 miles in 5 minutes. I'm going to divide. My first number always goes inside the bar. Second number underneath on the outside. So 5 goes into 6 one time. 1 times 5 is 5. Subtract, I get 1. I'm not going to leave the remainder of 1. Again, we can add a decimal and a 0, bring down the 0. 5 goes into 10 2 times. So this is saying that the cheetah can run 1.2 miles every single minute. Okay, now let's look at the leopard. Again, we're still comparing miles per minutes. So 3.18 miles he can run in 3 minutes. So I'm going to divide, bring my decimal point up, 3 goes into 3 one time, bring down my 1. 3 cannot go into 1, so again, bring up your 0. Now I can bring down the 8. 3 goes into 18 6 times. So the leopard can run 1.06 miles per minute. So now looking, which is the bigger number, 1.2 or 1.06? Which is 1.2, the cheetah. So C and D can be eliminated. Now, does the cheetah run faster by 0.0 or 0.14 miles an hour or 0.4 miles an hour? Again, to do this, I subtract. So I have 1.2 minus 1.06. Add that 0 to make it the same length. I can borrow from the 2. This becomes a 10. 10 minus 6 is 4. 1 minus 0 is 0. Or 1 minus 0 is 1. So our answer is the cheetah can run faster by 0.14 miles every single minute. So to recap, to compare unit rates and to compare faster rates, we find the unit rate of both items, both people, both animals. To figure out by how much faster, we subtract. The larger a number, the further somebody goes, the faster they are. So for the past couple of days, you have been finding volume of rectangular prisms, cubes, and triangular prisms. Now we're going to increase the level a little bit and work on multi-step problems with volume or ones where we have to work backwards. So let's take a look at number 1. Some of you might have done one of these problems yesterday, but we're going to review real quick. So here it says the volume of the rectangular prism is 540 cubic centimeters. What is the length of the prism? So right now, I don't know this length. I'm going to label it L. What I do know is I see we're talking about volume, and I see we have a rectangular prism. So automatically that tells me volume equals length times width times height. Automatically I write my formula. Now just like before, I'm going to plug my numbers in, except I need to be careful to figure out which numbers go with which variable. In the problem it tells me the volume is 540. So that means I need to plug it in under V. The volume is 540, so I plug it in under V. I now know the volume. I don't know the length. So if I don't know the length, I'm going to leave it as a variable. I know the width. Width goes from front to back. The width is 6. So I plug 6 in for W. And I know the height is 20. So I plug the 20 in for the H. Now I can solve what I have on the right side. So I'm going to leave my 540, that doesn't change, equals, I can do 6 times 20, which is 120. And then I'm going to bring down my L. I chose to put L now on the right side because in algebra we see the variables, remember, on the end on the right side. And the number before is that coefficient. So to get L by itself, I need to divide by 120. I have multiplication over here, 120 times L, so I do the opposite and I divide. And so 540 divided by 120 is 4.5 centimeters equals the length. Same formula, just a different place of where I plug my numbers in. Let's look at the second one. A sugar company wants to know how many sugar cubes can fit in one box. The box measures 9 centimeters by 8 centimeters by 3 centimeters. If each sugar cube has a side length of 2 centimeters, how many sugar cubes can fit in a box? So this is what a sugar cube box looks like. We have a regular rectangular prism for the box, and then if you see, there are little tiny individual sugar cubes. So we want to know how many of these little sugar cubes can fit inside this one box. So the first thing I need to figure out, well, how big is the box? So since I have a rectangular prism, my volume is going to be length times width times height. I'm looking for the volume. So it says the sugar box measures 9 by 8 by 3. When they give the dimensions, it's usually length by width by height. So I'm going to multiply these all out. 9 times 8 is 72. 72 times 3 is 216 cubic centimeters. That's how big the box is, how much it can hold. Now, I need to figure out how big is each little individual cube. If I have a cube, I know my volume formula is length times width times height. I also know that if the side length is 2, since it's a cube, the width is 2 and the height is 2. So 2 times 2 times 2 is 8 cubic centimeters. So my box can fit 216 cubic centimeters. Each cube takes up 8 cubic centimeters of space. So to figure out how many can fit, I need to divide my whole box. I'm breaking it up into little sections of 8 for each cube. So that means the box can hold 27 cubes. Try this problem on your own. So first thing, always write my formula. I'm talking about volume, and I'm talking about a rectangular prism, so V equals length times width times height. In the problem, it says the volume is 190. So under V, I'm going to put 190. It's asking for the length. So since I don't know the length, under L, I'm going to put L. I know my width is 4. Width goes from front to back. And the height is 5. Height goes top to bottom on a rectangular prism. So I'm going to leave my 190 over here. I can multiply the two numbers I have, 4 times 5, which is 20. Still multiplied by L, our unknown. So I'm going to divide both sides by 20. And I get a length of 9.5 centimeters. Go ahead and solve this second problem on your own. All right, this is similar to our sugar cube box. Inside this box of batteries is a bunch of little, smaller individual boxes. So the question's asking for how many of those boxes are inside. So first things first, I got to figure out, well, how much is the container, the bigger box? And it's a rectangular prism, which means I'm doing length times width times height. The dimensions are 10 by 9 by 4. Multiplying straight across, 10 times 9 is 90. 90 times 4 is 360 cubic inches. That is how big my whole box is. Now let's figure out how big each of these individual boxes are. The boxes are still rectangular prism, so it's going to be length times width times height. The dimensions are 4 times 3 times 2. Multiply 4 times 3 is 12, 12 times 2 is 24. So each box is 24 cubic inches big. So now I'm going to need to divide in this problem. My box is a total of 360 inches cubed. I'm dividing that into boxes of 24 cubic inches, and I get 15. So 15 little boxes of batteries can fit inside the larger box. Great job if you got this correct, and as always, be sure you make any fixes to any mistakes. Try now and solve number 3. All right, this problem was a little different. I have this Juicy Juice box right here. I want to know how much does the juice cost, or how much does it cost to fill the juice box. So in order to figure out how much it costs, I first need to figure out how big it is, how much space is inside. So if we're talking about cubic centimeters and we're talking about filling something, that tells us volume, length times width times height. The length is 3, the width is 2, and the height is 9.5. So here I'm just going to multiply straight across. 3 times 2 is 6. 6 times 9.5 is 57, so it can hold a total of 57 cubic centimeters. Now, I know that the juice costs 2 cents per cubic centimeter. So this is the unit rate. This is how much it's costing for 1 cubic centimeter. I don't just have 1 cubic centimeter, I have 57. So in this problem, we're actually going to multiply to get the cost. We're not dividing up the juice by cost. We have the unit rate, so we're multiplying 2 cents times 57, and we get $1.14 is the cost to fill the juice box. That was a lot of material today, so great job for sticking with me and working those problems out. All right, so if you are done early and you have gotten to this challenge part of today, I want to see what you can do with 2 challenge problems. So this first one, I want you to find the volume of this house. See what you can do, try your best, and then we'll go over it. All right, so this problem is really not that difficult. It's just 3 steps. So I see that this house is made up of a rectangular prism on the bottom and a triangular prism on the top. So if I want to find the volume of the whole house, I would just need to find the volume of each shape. So let's start with the rectangular prism. Volume equals length times width times height. The length of the bottom of the house is 12. The width is 15. And the height is 5. So when I multiply those all out, I get the volume is 900 cubic feet for that bottom level, kind of the first floor. Now I need to figure out the top part of the house, which is a triangular prism, because I have 2 parallel triangles. So it is a triangular prism. So here, this formula, remember, is base times height divided by 2. That gives me the area of this triangle. And then I need to multiply it by the 3D height or the depth. So the base of that triangle, I don't see a number, but if I know this is 12, that means this is 12 since opposite sides of a rectangle are equal. The height is 4, again because the 4 and the 12 form that right angle. Divide that by 2. Then the height is this line right here because it connects your two bases, your two triangles. In this case, it gives this house depth. So if this side is 15, that means this side is 15. Parentheses first, 12 times 4 is 48. 48 divided by 2 is 24. And then I'm going to multiply that by 15. So the volume of the top part of the house is 360 feet cubed. I just realized this should be cubed too. So since the house is both of them put together, I just need to add 900 plus 360, and I get a total volume of 1,260 cubic feet. Awesome job if you got that one correct. Here is our last super challenge of the day. See if you can find the volume of this composite figure. And I'll give you a hint. There is more than one way. There's at least 3 different ways you can solve for the volume. All right. So the biggest thing with composite figures is we need to break them into shapes that we see. So one way you could have done it is you could have broken it up into this longer bottom part with these top rectangles. So this would essentially be finding the volume of 3 rectangular prisms and adding them up. Or you could have seen it as breaking up this rectangular prism and this rectangular prism, and then this middle one, or this middle part right here. Since I have this outline, I'm going to go ahead and solve it this way. If you did it the other way, you should get the same answer. So I'm going to look and I'm going to label these A, B, and C, my 3 sections. So let's solve for the volume of A, which is going to be length times width times height. So the length of this rectangular prism is right here, which is 3, because if this side is 3, this side is 3. The width goes from front to back. Over here, I see that this side is 3, which means this side over here is 3. So the width is also 3. And the height up and down, if this side over here is 8, this side over here is 8. So I get 3 times 3 is 9. 9 times 8 is 72 cubic centimeters for that one side. Side B should be the same. The length right here is 3. The width front to back is 3. And the height is still 8. So same volume. This part right here is a little trickier. Here, the length is only this part. This whole side is 12. So if I'm just looking for this red part, that's not going to be 12. But I know that this whole side is 12. I also know that 3 centimeters is taken up on this side and 3 centimeters is taken up on this side. So that's 6 centimeters that's already gone, which means this tiny part is 6 centimeters. The width is still going to be 3. That didn't change. Now I just need the height. So again, I know that the whole height is 8. I see that already 5 centimeters is taken up from this top part, which means the height of the bottom part is 3. So our length we said is 6, our width is 3, and our height now is 3. So 6 times 3 is 18, and 18 times 3 is 54 cubic centimeters. My last step is to add those up. So 72 plus 72 plus 54. 7 and 7 is 14. So we get a total of 198 cubic centimeters. If you got to this, that is awesome. Great job today and all your hard work.